at this table, because this table we're going to start off with the things that we know, which is like 3 to the 4th power. What is the 3 in all of these powers? What do we call that big number? The base. Good. So in this first one here, we have 3 to the 4th power. You got it. All right, so 3 to the 4th power. Our base is 3. And how many times are we going to multiply 3 by itself? 4 times. So we're going to do 3 times 3 times 3 times 3. Try and fit that in. I know you have to write kind of small. Jorge. You guys can talk during work time. Alright, so what is, you guys, 3 times 3 times 3 times 3? What's 3 times 3? 9, and 3 times 3 is? 9. So 9 times 9 is 81. So 3 to the 4th power is 81. Okay, and then we have 3 to the 3rd power. So how many 3's will we have there? 3. 1, 2, 3. So we're doing 3 times 3 times 3. What's 3 times 3? 9. 9 times 3 is 27. Okay, Abdirahman, put that away and do this with us. Otherwise, you're not going to know how to do this test.
Yeah, I do know.
Hey. 3 squared. I appreciate that, but I got it. 3 times 3. I'm a strong, independent woman. 3 times 3 is 9. Good. All right, now when I just see 3, what is the exponent of 3? 1. Good, just 1. So how many 3's is that showing? 1. Just a 3. Good. And what does that equal to? 3. All right, so a couple of ways to think about this. Hey.
It's just because I wrote a 3 instead of a 7 and instead of a 2.
Okay. All right, a couple ways to think about this is, one way we can think about it is by doing that 3 to the 4th. As I go to the left here, how are these numbers changing? What are we doing every time? 3 to 9 to 27 to 81. What are we changing every time?
It's adding a 3.
Multiplying by 3. We're adding another 3 that we're multiplying. Good, so we're multiplying by 3 as we go to the left. So if I go to the right, how are we undoing multiplying by 3? What's the opposite of multiply?
Dividing.
Dividing, good. So we're going to divide by 3. So 81 divided by 3 is 27. What's 27 divided by 3?
38.
No. 9. 9 divided by 3 is? 3.
5.
So no matter what I get in this one here, if it was 2 to the 1st power, I would just get 2. 1 to the 1st power, I would get 1. 10 to the 1st power, I would get 10. Either way, I'm always going to be taking this number and dividing by itself to get that next number. So what is 3 divided by 3? 1. Hey guys.
I'm not even talking to her.
Yeah, you are.
I'm
Yes, you
talking to
are.
myself. I'm talking out loud.
No.
No, yes.
Alright, 3 divided by 3 is 1. Okay, and one way we can think about that is that we're dividing by 3. That's our pattern every time that we go down. So as I subtract 1 here, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, 1 minus 1 is 0, but 3 divided by 3 is 1. Another way we can think about it is that there's no 3's here. So what number is always kind of secretly hiding? A 1. Okay, so our 0 exponents, anything taken to the 0 power is always equal to 1. Anything taken to the 0 power equals 1. Because no matter what number we have here, we'll have to divide it by itself. And if I have like 5, what's 5 divided by 5? 1. What's 10 divided by 10? What's 36 divided by 36?
48.
1. Okay, stop.
I was kind of wrong.
Okay, so we always get 1. So now we need to get into our negative exponents. So we could continue to divide by 3. Holy side comment. So one way we can do this is we continue to divide by 3. So if I go to my calculator and I do 1 divided by 3. Again, this is Desmos. You all have this on your computer. 1 divided by 3. Yeah, I hit that fraction button and it's really just 1/3. So 3 to the negative first power is 1/3. Alright, now to get to this negative second power, I'm going to again divide by 3. So I'm going to take that 1/3 and I'm going to divide by 3. I'm going to make it a fraction and we get 1/9.
Wait. Oh, wait. Is that 1/5 or 1/3?
1/3.
Oh, my fault. I'm blind.
Alright, now we could put it in our calculator. Our calculator does know how to do negative exponents with actual numbers. So I could put in 3 to the negative third power. And we get 1/27.
4?
9.
9? Oh, yeah, I just saw that.
Can anyone predict what's this last one going to be?
81.
1/81. Good. How did you know?
Because, like, we're following the same thingamajiggy.
Yeah, well, it's following this pattern from that 1 as I work my way out. It's like 3, 1/3, 9, 1/9, 27, 1/27, 81, 1/81. So this 1/3 is just 1/3. We have 1/3 on the bottom. Hey, Ali, stop, guys. So now with 3 to the negative second, we're going to multiply by another 3, but on the bottom. So it's 3 times 3. And 3 times 3 was 9. So now we have 1 over, how many 3's will be on the bottom? 3, because it's 3 to the negative third, so there's 3 3's. 1, 2, 3. Another way to do this is we could put this as 1/3 to the what power? 4. Follow. So much happening right now.
I'm on 91%.
Yeah.
Is that good?
Alright, so for negative exponents, we need to flip it. Like it flips upside down. So what do we, does anyone remember, what do we call that with a fraction when a fraction flips upside down? No, it starts with a reciprocal.
Mr. Chill.
Okay, reciprocal, which means to flip.
Miss, I was showing him a funny video.
Okay, so we rewrite as a reciprocal, which means to flip it, and we do a positive exponent. I mean, you got this written down? Put your phone away. Not in your lap, put your phone away. Okay, so a to the negative x power. This one, I don't really love these, but they're there for us to kind of show what they mean. So this is like it's over 1. So because I have a to the negative x, alright, so a to the negative x, is that going to stay on top, or does that flip to the bottom? It flips to the bottom, the reciprocal, and then the x becomes positive. What's left over on the top then? A 1. Good. Very nice. Okay, so on this next one, now if I have a negative exponent but it's already in the denominator, where would that flip to? The top, the numerator. Good. So is this 1 going to flip? Does it have a negative exponent? No, so the 1 stays. Is the 4 going to stay or does the 4 flip? 4 stays. Abdi Fatah, there's a reason you don't sit there. Hassan, there's a reason you don't sit there. Alright, a to the negative x is on the bottom. Where does that has a negative exponent, where does that need to go? To the top. When it flips to the top, it becomes a positive x. So 1 times a to the x, we can write it as just a to the x power over 4. Alright, I'm going to say that how many examples we have, and we're going to all be like, oh my gosh, that's so many. But it's really not that bad. The first 3 are just kind of these basic ideas. Okay? There's 5 examples total. Alright, so here we go with example 1.
Miss, could you scoot it down a tad bit?
Down?
No, a little up on it.
Well, you should have already had that stuff.
No, power equals.
1, we filled that out like 10 minutes ago.
Yeah, that's the only thing I
Hey,
did.
stop.
See?
Okay. Alright, number 1, we have 2 to the 3rd power, y to the 0 power, over 2 to the 6th power. Okay, Brian, move. Brian, move. Here. Move.
What do you do?
Move. Move.
Bro, it's not it today, bro.
Alright, so what do we notice about this? What needs to change? How can we simplify this? Yep. What part needs to simplify? I mean, phone away. Nope, not in your lap, I mean. Okay, so what do we see about this? What can we simplify? We have these 2's on top and bottom. Shh. So if I have 2's on top and bottom, are we going to add, subtract, or multiply those exponents? It's good. We're going to subtract. So what is 6 minus 3? 3. And are they left over on the top or on the bottom? Where did I have more to start with? The bottom. So we're going to do 2 to the 3rd power on the bottom. And on the top, I have that y to the 0 power. Okay, now we're going to simplify that. What is y to the 0 power? 1. Good. Anything taken to the 0 power is 1. So on the top, we get 1. On the bottom, we're doing 2 to the 3rd power. So 2 times 2 times 2. 8. Good. So 1 over 8. And that's our simplified answer. Okay, now that was a numerical one. That's a number that we can actually get an answer to. Okay, number 2. Now we're going to start introducing more variables. Okay, so number 2 we have in parentheses. This one you want to keep up with as we write, because it's going to be a lot. Enoch, what do you need? We have x to the 5th power, y to the 3rd power, z to the 4th power, times x to the 2nd power, y to the 6th power. Okay, write this down, Abdirman. Let's go. It's a lot. Okay, so in parentheses, x to the 5th power, y to the 3rd power, z to the 4th power, times x squared, y to the 6th power. And then it's going to be all taken to the 0 power. So as we look at this, a z to the 4th power, x to the 2nd power. So as we look at this, there's lots of things to simplify. Which are some of the bases we could put together?
Y and X.
The y's and the x's. And we'd say, okay, we have 5 x's and 2 x's. So how many x's together? 7. How many y's together? 9, but that's too much work. Because overall, what am I eventually taking this to the power of? 0. And when I take something to the power of 0, my answer is always
0.
anything taken to the 0 power is always 1. Like 4 of you were saying that, and then 4 people were saying 0. So, want to make sure it's 1. Done. That's it. We got it. All right, number 3. Number 3, we're going to start including some fractions. So when I do fractions with the exponents, I like to take up 2 lines. Otherwise, my exponents get so small, it's hard to read them. So here I'm going to have n to the negative 6th power, p to the 4th power, over r to the negative 3rd power.
P.
Can you turn it down? It's real loud. Thanks. Alright, so in this one, do we have any bases that are the same? No. So we aren't going to combine anything. We're not actually going to multiply, add, or subtract our exponents. But we never want to write our answer with negative exponents. That's just too confusing for our reader to understand. Okay, we know what p to the 4th is. That's p times p times p times p. We can write that out. But we want to be able to write it out with those n's and those r's. So we have to do that idea of flipping. So I'm going to take that n to the 6th power and that r to the negative 3rd power. Those need to flip. So where should n to the 6th power go? Should it stay on top or move to the bottom? Bottom. And when it moves to the bottom, that n moves to the bottom. That negative 6 is a positive 6. Good. All right, what about this p? Is the p staying on top or moving to the bottom? Does it have a negative exponent? Nope, so it just stays. Only things with negative exponents need to move. So p to the 4th stays on the top. What about this r? Should the r stay on the bottom or move to the top? Move to the top, good. When it moves to the top, it's going to be r to what power? 3. Now, we said there is no same bases, so this is as far as we can go. All right, now number 4 and 5, we're going to start combining some of the days that we've been doing. So these ones are a little bit more multi-step. Yeah, we're doing notes. Number 4.
Miss, how many more?
2 more. We're doing 5 total. All right, number 4, we have 5. R to the negative 3rd power. T to the 4th power. Over negative 20. R to the 2nd power. T to the 7th power. Alright, so there's a couple things here that we need to simplify that when we look at this problem, it looks like a lot. Our answer is going to actually look a lot easier to work with. So what are some things here that we see that need to change? I mean, put your phone away. Good, there's R's, there's multiple R's, and there's multiple T's. What else do we see? A negative. So let's start with that negative 3 first. That negative exponent. So let's go one by one and decide, are they going to stay or are they going to flip? So does 5 stay on the top or is it going to flip to the bottom? Stays. Good, because the exponent is 1. T to the 4th, or sorry, R to the negative 3rd, does that stay or flip? That'll flip. I'm going to put that at the very end, R to the 3rd power. And does t to the 4th power stay or flip? Stay. Okay, now this is the tricky one. Does negative 20 stay or flip? When do things flip? When they have a negative exponent. Does negative 20, what's the exponent of negative 20? Just 1. Remember, it can be taken to the first power. So negative 20 isn't an exponent. It stays on the bottom. What about r squared? Will that stay or flip? Stay. And then t to the 7th power? Stay. Alright, so now that we have positive exponents, let's deal with those positive exponents. So do you want to do the r's or the t's first? What makes you happy? R's. Okay, so I have r squared and r to the 3rd. They're on the bottom together. So when they're on the bottom together, we want to count how many r's together is that. If I have 2 r's and 3 more r's, all together that would be 5 r's. So r to the 5th power. We add those exponents when they're together. Okay, what about our t's? How am I going to deal with that t to the 4th and t to the 7th power? Good, when we have them on top and on bottom in a fraction, we subtract. So 7 minus 3, 7 minus 4 is 3. And those leftover t's, are they going to go on the top or on the bottom? Bottom. Now there's one last thing that this one has a little bit of a trickster on it, is this 5 over negative 20. We need to look at that as a fraction. So I need to simplify that, and I'm just going to use my calculator to do that. So 5 over negative 20 simplifies to negative 1/4. So on the top is going to be that negative 1. And on the bottom is the 4. All right, we have one more problem. Again, these are multi-step problems, so we're combining all the information we've learned from all the exponents. Last one, number 5. What's happening? All right, last one, number 5. We have on the top x to the negative 4th power, y. And we're taking it to the 4th power over 2x to the negative 3rd power. Last one.
Say square.
Swear. Will I?
What'd you say?
Alright. No one's going to the bathroom right now. No one's going to the bathroom right now. Oh. Yeah, I said no one's going to the bathroom. That's what I was saying. Audi Fatah, last one. Go write this down. Alright. What's our first thing we're going to be doing here? What? We need to deal with these parentheses. That's our first step, is the parentheses. And when we see parentheses, what do we do with our exponents? Multiply. So we have x to the 4 times negative 4. 4 times negative 4? Multiply. Negative 16. And then this y has an exponent of what? 1. So it's 4 times 1 is 4. So first step is parentheses. Now what are we going to do? We could simplify the x's. I like to not deal with those negative exponents, so that's how I do it. There's a couple ways to do these problems. I like to not deal with negatives. To me, that gets really confusing, and it's too much to deal with. Because then I get confused, does it go on top, bottom? I don't know. When I have positives, it's easier for me to see it. Some people can handle those negatives. They're just smarter than me. So this x to the negative 16th is going to go where? To the bottom. Y to the 4th stays. 2 goes to the bottom. I mean, your music is so loud, dude. And then x to the negative 3rd, is that going to go to the bottom or the top? It was on the bottom. It has a negative exponent, so now it's going to go to the top. Holy cow, we got one last step here. What's the last part that we need to do to simplify this? Good. Now we are going to look at those x's on top and bottom. When you have x's on top, x's on bottom, we subtract. So 16 minus 3, 13. And are those 13 x's going to be on top or on bottom? Where are the leftovers? Bottom. So what feels a little silly today is that we're doing all these things that we know how to do. It's going to be just taking it step by step, one thing at a time.